Hi guys, I wanted to introduce you guys to something very interesting I found. It's actually a platform where you can program very well, learn how to program, do a whole lot of tasks on your mobile phone. It is easy, trust me, it is super easy. Now, this app I want to introduce you guys to, I will actually, over the course of a period, I will probably be dishing out tutorials on how to program in Python, and I'll be using this platform. I am going to dedicate a new YouTube channel to this, which I think I have done already. For you to be watching this, you're probably watching it from my YouTube channel. Now, I am going to be doing every video I'm going to be doing on this channel is basically going to be from this app. We'll run a few stuff, all the basic stuff that this stuff can do, we'll play around with it. And um, during the process, I believe most of us will learn how to program very well. Now, let's just dive straight into what we're supposed to do. Now, the app I'm trying to talk about is the Pydroid3. That is the app and the um, right beginning. That's if you're beginning from your right, the first app you see there, the blue one. Now you can easily download this from Google Play Store. Just type in Pydroid 3 and then you'll find the app. This is the logo you download, and then once you open it, you basically find something like this. This is a plain text. This is an IDE. Just a text IDE. You can type in things and then save files, create files. Now I would basically want to start a project on this. Work as if I'm working on an ID for my system. Um, um, okay, now to start a project, let's just say I want to create a file, and let's say I want to save this file as I would like to. Usually, this is the home directory where it will show you, but I always like to go into my internal storage and then create a folder where I can do my Python um, projects or whatever. But for me, I created the py folder. Now inside the py folder, I will use uh, I think I would use this. I would use this. I already have an app.py already there, so I would select this folder and create a new file, and I'll name this okay, uh, we want to probably do, uh, let me call this a Fibonacci. I just feel like doing something concerning Fibonacci. So I call this Fibonacci.py. We'll save this. Now we have created our Python script, our Python file or app, whatever you want to call it. Now in here, you can just easily do things. You can this is a pretty this is a pretty IDE. You can just easily do print. Sorry, if I could type print. Um, let's say we want to print. Hi guys. Um, uh, this is an exercise done by Pydroid 3. Now, I run this, we get that. Hi guys, this is an exercise done by Pydroid 3. Now, this is you can do every of your Python, whatever you want to do here. You can do every one of them here. Now, let's dive straight into business. Now, I want to create I want to do an app that can actually give me Fibonacci sequence, uh, depending on how many number I give to it, or what range I want to give to it. Now, we can do this by saying we declare a function. Now, to declare a function in Python, we use a def. Um, Over time, I'm going to probably run some more intricate studies for pure beginners. This is for those who probably have a little idea in programming but probably want to dive into Python and you know and want to do it via phone. Why not? It's easy. All right. Now back to work. We do the Fibonacci. Oh God, if I could spell Fibonacci, and this Fibonacci function is going to collect a parameter. We'll call that parameter probably the nth term. Now, for us to get this done, I can say if here first off, before we start working on this, I want you to first of all know what Fibonacci sequence are. Fibonacci sequence. Um, I will first of all call the sequence, I'll write it out, and then I tell you what is actually happening. Now, some people want to believe that Fibonacci starts with zero, while some zero and one. Some people want to believe that, while some want to believe that Fibonacci starts from one and one. Now, whichever you choose is correct. The sequence still goes the same. I don't know the ideology behind the zeros and the one, but personally, I just prefer to start with zero. Now, so here's a Fibonacci sequence. You just do zero. So it starts with 0 and 1. Now, to get the next value in the sequence, you'd have to add the previous two, which is adding the 1 and the 0. That gives you a 1. Now, this is why people say it starts with a 1 and a 1, not a 0 and a 1. Now, after this, the next sequence on the line would be the sum of the last two values in the series, which is in this case now it's 1 and 1, so that makes it 2. Then the next sequence will become 1 plus 2, which are the last two values of the sequence. It becomes 3. And the next one becomes 3 and 2, which becomes 5. The next one is 3 and 5, which becomes 8. The next one is 5 and 8, which becomes the 10. I hope you get the idea now. So I won't go too further, but it just keeps going like that to whatever, no end. You just, the circle keeps going. Now, we want to create a function that actually develops this sequence for us, calculate it for us very fast. Now, in order to do this, would find a way to be able to get the um, um, last the values of the last two sequences. mm? We need to find a way on how to get those values. But before that, there are some checks we need to make because this sequence is going to start from somewhere. So in order to that sequence, for us to get that sequence, we'll do something like this. We'll do if n is equal to 1, which could be the first sequence, right? Which is the first type of the 0 and the 1 added together. If it is equal to 1, then we'll return a 1. Now, else if, a leaf, that is the way you call it in Python. It's for those who actually are coming from other programming background, they would probably understand what the else if conditional statement means. So we do elif n equal, sorry for the noise on my background, there's lockdown, so everybody's at home, so everyone is definitely going to talk. Let's go back to what we're doing. I'm sorry if the noise is actually disturbing from the background. Now, if n is equal to 2, which is the second scenario I gave to you where people argue that a Fibonacci sequence begins with a 1 and 1. So if it is equal to 2, we would still return a value to be 1. Now, elif n is greater than 2, our sequence begins, right? So now let's sum up for our sequence. In order to get this, we'll return the sum of Fibonacci, if I could spell Fibonacci, of the second to last, the last Fibonacci of the last sequence plus Fibonacci second to last sequence. So with this now, we should be able to get our Fibonacci sequence. So let's put this to test and see what we're going to get. And so for that, for us to put it to test, we have to do for, let's say I in range, for I in the range of um, um, 0 to 10, or I could say 1 to 10, um, we should print the result of Fibonacci for that I10. Now, if we run this, okay, sorry, we haven't. Sorry, forgive me. It's a free app, so you definitely get them do this. This is how they make their money. But it's an amazing app anyway. Now, if you run this, you get this. Now, this is the first 10 sequence of the Fibonacci, of that Fibonacci sequence. Now, beautiful. We've done something amazing. We've been able to shoot out something. Now, this function works actually. That was what I was trying to say. Rather, the function works. So now, if we have, say, we want to get the first 100 sequence of Fibonacci. Now watch what's going to happen. Uh oh, the system is getting slow. It's no longer loading as fast as it used to load before. Now this problem can be easily fixed. And in order to do this, we will introduce a Python technology or an idea called Memoization. Do not think I spelled it wrong. This is the correct spelling. It's called memoization. Um, it's actually a practice that involves or a practice that records um, um, intermediate um, functions in the system and doesn't allow for recursive function requests, whatever. I don't know how to start making that big. Now, to make it a little bit broken down for you, is the idea is it saves a certain function. Now, instead of you recalling that function again, it gives you the result of that function itself. So the system, the machine no longer works. It just collects a certain value. Now, in order to do this, we're first going to declare a variable or a dictionary outside. We'll call this dictionary Fibonacci cache. That's what we call it. Sorry, I wish I could just spell today. And we'll equate this to an empty dictionary. Now, we'll come inside this function and we'll do something like this. We'll say if n in Fibonacci cache, if n is in there, what we'll do is we would return that we'll return Fibonacci cache of that term. Sorry, Fibonacci cache of the nth term. We'll return it. Now, if we do this, the next thing we have to do is we'll come here and instead of having return 1, we'll assign a value. We'll assign a variable. We'll assign 1 to a variable called value. Then we'll come here, and instead of doing this return as well, we do value, and then we'll come here, instead of doing that, we do value as well. But then we'd come here and declare value as to be equal to 0. Now this is going to change every time it meets any of these conditions below. So we will now come back here and say Fibonacci. We need to append this particular value to the Fibonacci cache to memorize it. So next time this function is running, it already knows, okay, I've run this function before, I'll just have to call out the result. So we assign this to the Fibonacci dictionary already. So we do Fibonacci underscore cache will be equal to value. Now we return. Oh God, if I could spell today. We return value. Sorry, I'm trying to make this class as fast as I can because of the noise in the background. All right. Now, with this now in place, we'll save. We'll save first, and then we'll run this code. Oh no, I think we have a problem. Local variable referenced before assignment Fibonacci cache. Let's go back and see if we had spelled something wrong here. Fibonacci cache has been declared outside Fibonacci cache. Oh, sorry. This it is not. Oh, sorry. This is not Fino. It's Fibo. Oh God, help me if I could spell here today. Okay, I think we should be good by. God, not again. What is it this time? On line 8. Fibonacci cache. Line 8. If n in Fibonacci. What could be wrong here? Okay. I am still trying to find where our problem is, or where our problem is coming from. Fibonacci, Fibonacci sequence, Fibonacci cache. Oh, all right. I think I found where our problem is. Is the assignment of the Fibonacci cache. What we should have done here is we assign the Fibonacci of that nth term into that stuff, and let's see if this will work this time. Hopefully it does work and we don't run into another error. Alright, now you see, now our speed is awesome. Our speed is just awesome. Now I would want to test this stuff, just try my luck. Sorry this keeps showing the ad. Is the regular thing, is a free app. Um let's say I want to try my luck. Let's just try and get the first 1,000 and see if this is going to get slow. And we'll save, and then we'll run this. No, it's not slow. It came out super fast. So we've been able to actually make our machine work very effectively using memoization. Um, I think this is beautiful enough for now, but then I would run another video that does a more extensive way of making this code shorter and more effective. And thank you guys for watching. I hope you enjoyed this short series. I would make up some stuff if you like. So if you probably want me to keep making more videos like this, just please comment down below and subscribe. and click the bell icon so you get notifications every time that I post something. Then let's just start up something. This could just be the beginning of a new amazing network. Once again, thank you guys for watching, and do have a lovely day.